Hello friends. In my last session, I told you the concept of crosswind component. And crosswind component is important when you orient the runway. And I told you in my last session that the runway is oriented in the direction of prevailing wind. Once the maximum crosswind component is decided, the most desirable direction of runway for wind coverage can be determined by examining the wind conditions in three cases. The first is the entire wind coverage regardless of visibility and cloud ceiling. When I say cloud ceiling or ceiling, it means the height of the cloud. The second condition is when the ceiling is at least 300 meter, that means cloud is at least 300 meter above and visibility is at least 4.8 kilometer. And third condition is when the ceiling is 60 to 300 meter, between 60 meter and 300 meter, and the visibility is between 0.8 kilometer and 4.8 kilometer. These three conditions are generally considered when you study the wind characteristics. Now, the first condition here represents the entire range of visibility from very excellent to very poor, and it is termed as all-weather condition. The second condition represents the range of good visibility, not requiring the use of instruments for landing, and it is termed as visual meteorological condition. Meteorological conditions, VMC. And the third condition represents various degrees of poor visibility. It requires use of instruments for landing, and therefore this condition is termed as instrument meteorological condition, IMC, instrumental meteorological condition. The criteria which is fixed by ICAO or FAA for 95% of wind coverage basically is applicable to all conditions of weather. But it is still useful to examine the wind data in parts wherever it is possible to see what duration of the time in a year falls under this category, what duration falls under this category, and what duration of the time falls this condition. To draw the orientation of the runway, wind data are collected for at least 5 years and preferably for 10 years, and these data are analyzed graphically. These data are for direction of the wind, duration of the wind, and intensity of the wind. And this graphical representation of wind data, which is used to orient the runway, is called the Windrose diagram. Windrose diagram. And there are two types of Windrose diagram, type 1 and type 2. It only uses the direction and duration of the wind. In type 2, we use direction, duration and intensity, all three, and therefore this is more accurate. Intensity of wind. But even for type 2, you need to draw type 1 just to get the idea of probable runway orientation. Now let me just explain these two with the help of one example. So wind data are collected for a city for last, let us say, 10 years, and the average data are given in this table. So you have now 16 directions in this table, and for each direction, the duration of the wind in percent and speed of the wind in the range. Range starts from 6.4 kilometer per hour. Because if you remember, I told in my last session that if speed, the wind velocity is less than 6.4 kilometer per hour, it is considered to be the calm period. It doesn't affect the landing and takeoff operation of aircraft, and the crosswind component will be insignificant. So generally 3 ranges are taken from 6.4 km per hour to 25 km per hour, from 25 to 40, and above 40 to 60 km per hour. Now here we consider 16 directions. This is north, east, south, and west. And this is northeast. This is north, northeast, east, northeast. And similarly, you can mark all the directions. Southeast, east, southeast, south, southeast, and this is southwest, south, southwest, west, southwest. And wind is considered blowing from a cone of 11.25 degree in each direction. This is the cone. East, northeast is considered if the wind blows within this cone 11.25, that makes 22.5 degree. So wind blowing in a cone of 22.5 degree is considered as blowing from a particular direction. Now we, in this type 1 Windrose diagram, we draw circles here, and these circles represents the duration of the wind. You can draw these circles to some scale. Let us say this inner circle is for 5%, this is for 10%, this is for 15%. 15% duration of the wind coming from a particular direction. So radial line here indicate direction, and circle represents the duration of the wind. Now from this table we plot all these data which are given in the last column, that is total duration. For example, 2.5% time in a year the wind is blowing from north direction. So you plot 2.5 here on the direction of the north. 8.8% time in a year it is from north northeast. So 8.8 will be here. That is another point. Next is 14.6% from northeast, somewhere here, 14.6. You will draw it on a graph paper to the scale. Then 9.5%. 9.5% is here. Here. Similarly, you plot all these data which are given in the last column, and these are the points starting from north, northeast, northeast. Now you join them. You join all these points by straight lines. Let us say from this point you draw all these lines. Now this is what we call the Windrose diagram. Windrose diagram of type 1. Join all these points by straight lines. and the runway orientation or center line of the runway will be along the line of maximum values. So here in this case it is northeast to southwest. Northeast, southwest is the runway orientation. Now let us see how much is the wind coverage on this orientation. So if you take the wind duration during northeast and southwest, it is 14.6, it is 9.8. This is the percentage of time, that is 24.4% time in a year. The wind will truly blow from either northeast side or from southwest side. But this wind coverage is not sufficient. We may allow some deviation in the wind speed, and therefore if you allow a deviation of 11.25 degree, what does it mean? I told you that this direction basically covers this cone here from cone of 11.25 on either side. If you take further 11.25, it will reach up to this point, northeast. And reason is that sine 22.5 degree is 0.38. And if you take sine 22.5 plus 11.25, that is 33.75, it is 0.556. So even if the wind is very strong, say 60 km per hour or 40 km per hour, because if you see this table, there is very small duration of the time in a year when the wind is above 40 km per hour. So for a speed of 40 km per hour also, the crosswind component will remain within permissible limit of 35 km per hour. So if you allow this deviation, then you can add this value also, you can add this value also, and you can add this value also and this value also. So you can add all these values from west, southwest. You have a value of 9.8, 9.5. Take total sum. Now, if you look at the table, the data, wind data which are given in the question, the total sum of duration in the last column is 90.9%. That means the speed will be less than 6.4 km per hour for a time period equal to 100 minus 90.9. So calm period here will be 100 minus 90.9, that is 9.1%. And I told you this is the period when crosswind component not significant, and therefore you can add this value also here in this column, and that will give you the total wind coverage. And this wind coverage should be 95% for small airports and 98% for busy airports. If one runway does not provide you enough wind coverage, then consider making a second runway perpendicular to this runway. Now this is the direction of the runway which you got from this. So if this one doesn't provide you complete wind coverage of 98%, then you can consider another runway at 90 degree or at some other angle with this runway. That is how you mark the center line of the runway in a Windrose diagram of type 1. Now here we did not consider the duration of the wind, that is wind speed. In type 2 we consider wind speed also, and therefore in type 2 this cone of each direction is considered. This is the cone. Cone means basically wind coming from within this cone is considered as wind coming from southeast. So rather than drawing this radial line exactly at the direction, we draw a cone of the direction in type 2. Let me draw that. So these are 16 directions. Now you can see here, this is the true east, but actual cone is taken on 11.25 degree on either side of true east. So this is the direction east rather than a single direction. That is the difference between type 1 and type 2. Similarly, this is true north, but wind coming within this cone is taken as the wind coming from the north direction. Now, these are radial lines, which basically not radial lines, but these are the cones, radial cones, which represents the direction. And you draw here circles to represent the wind speed. Let us say the inner one is 6.4, then next is 25. So you draw a circle here at 25. Next is your 40. Draw another circle at 40. But all these must be drawn at some scale. And last one is 60. So this inner one is 6.4. This is 25. This is 40. This is 60. Now you enter all these segmental values of duration with respect to speed range in each segment here. For example, if you take north direction for a speed of 6.4 km to 25 km per hour, duration is 0.4. Now this is the segment 6.4 to 25, right here 0.4. That is duration. Similarly, 25 to 40 km per hour, it is 1.7. And next is 0.4. Fill all these values. For north, northeast, this is 2.1 here, from 6.4 to 25, 5.8 in the next segment, and 0.9 in the next segment. Similarly, you enter all these values. So you can now fill all these values in respective segment. Now take a transparent sheet like this and draw 3 lines here. One at center and 2 outer lines, and this spacing is equal to the crosswind component, which is permissible. 30 km per hour, 35 km per hour, 25 km per hour, whatever you take in your design. But this distance should be taken the same scale as the scale of Windrose diagram. So here if you have taken this 0 to 40, this is the distance for 40 km per hour. Similarly, you take this distance for 30 km per hour, 35 km per hour. Now you place this sheet on this Windrose diagram in such a manner that the center line passes through center of the diagram, and then you see what are the values which are inside the outer lines here. Take sum of all these values, and if a particular segment is cut partially, you take its partial value. Say for example here 0.6, this is cut partially, so you take only 0.4. Take sum of all these values. Then rotate this about the center and again count all these values and take the sum. Make 3-4 trials till the total sum of all values which are inside the outer edges of this transparent sheet, outer line of transparent sheet, is maximum. And that is why I told you that it is always better to have type 1 Windrose diagram first, so that you get the idea of probable orientation, and then use this type 2 diagram to find out the exact direction. So total wind coverage will be now, sum of all these values, sum of all values within the outer lines of this plus calm period. And I told you, if a particular segment is cut partially, you take proportionate values of that segment and take sum of all these values, that is the total wind coverage. This should be 95% minimum or 98% desirable. If again a single runway does not provide the total wind coverage, then you consider having a alternate runway at 90 degree to this. So that will be secondary runway and this will be the primary runway. Thank you very much for watching this video. You can write a suggestion in the comment box.